Hello, hello! Topic 1, guided notes. We are looking at atomic structure, topic 1 in unit 1 on atoms. So our expected goal today is to draw and label a basic Bohr model of an atom, identifying its atomic number, protons, electrons, neutrons, and mass number. Let's get started. So matter, first of all, makes up everything, and there are two basic definitions to start with. An atom then being the smallest unit in which matter can be divided without the release of electrically charged particles, and an element, which is a substance in which all the atoms in the sample are alike. So atoms are the small things. An element then is a type of atom. So you probably heard of the periodic table of elements. Those are the different elements, and then there are atoms of each of those that make up all of matter. So we have two other words here, molecule and compound, that we need to work on a definition for. So pause the video, take a look at this image, and try to come up with a way to describe what a molecule is versus a compound based on the images given here. So we have an atom of helium as our example of what an atom is. We have one circle with He, which is the symbol, which we'll get to in a minute, for helium. Molecule, we have two H's together, and then in a compound we have two H's and an O. So hopefully you've noticed that in the molecule there are two of the same type of atom making up that molecule, and in the compound there are two or more types of atoms making up that compound. Subatomic particles, these are our big points for this topic. We are going to look at protons, neutrons, and electrons in just a second using this basic structure of an atom. Protons we identify with a small p. They are used to identify the element. I will say that 300 times. Protons are what identify the element. If I have 10 protons, I have neon. If I have 2 protons, I have helium. I do not have helium if I have 3 protons. I have lithium. The number of protons identifies the element. Positively charged particles in the nucleus, those are where they are located. Electrons we denote with an E with a little superscript negative sign. They are negatively charged particles, and they are found in the electron cloud. So outside of the nucleus are where we find those electrons. Ions are formed when atoms gain or lose an electron, and we can use this simple equation here to find out either how many electrons we have or what the charge is. We always know how many protons there are, again, because we look at the periodic table. This top number, which we'll get to in a minute, tells us the number of protons. So if I have a +1 charge, that means that I have less electrons than I have protons. If I have a -1 charge, that means I have more electrons than protons. Last up, we have neutrons. Neutrons are the neutral particles in the nucleus. They aid in stabilizing protons. Isotopes are made when atoms of elements have different numbers of neutrons, and we can use this mass number to find the total number of neutrons. Mass number is not on the periodic table. I'm going to go back to the periodic table picture again. This bottom number here at the bottom of the periodic table is not, let me repeat, not mass number. That is the average atomic mass, and we will talk about that in a later topic. Mass number can be found then by adding the protons and the neutrons together. So, chemical symbols, this is what we see on the periodic table. We will always use P table when working, and that's what's on your table as well. The top number is the atomic number. It tells us the number of protons and helps us identify the element. The symbol is a short 1 or 2 letter abbreviation for each element. The first letter is always capitalized. So here in helium, H is capitalized, E is not. This is one atom. The biggest example that I like to use is CO for CO. So the first example, the C is capitalized, the O is not, and the second example, the C and the O are both capitalized. The first example here is cobalt, which is a transition metal towards the middle of your periodic table. This is a compound made up of carbon and oxygen. It is actually carbon monoxide, stuff that's produced in your car. The last number is the atomic mass. Again, this is the average atomic mass of all the naturally occurring isotopes. And so this is not our mass number, but this is an average. And we'll talk more about what that is and how we calculate it in a later topic. So a quick little check for understanding. Pause the video and try to answer through these questions. All right, hopefully you have an answer written down for these. We are identifying which subatomic particle is responsible for each of the following. Number 1, an atom of an element is found to have a charge of +1. If I have a charge, I am forming an ion, and if I go back and look at my notes, Ions are formed when the electrons change. So I either have, in this case, because it's +1, I have less electrons than protons, meaning I have an ion. Number 2, the atom is found to have a mass number of 14. Mass number is made from protons and neutrons. Because protons change the type of atom we have, we must be looking at neutrons here. Which number 3 leaves us with protons. Remember, identifying the element. The particle which identifies the element is the proton. A couple other questions. Again, use P table or the periodic table at your table to answer these. So pause the video and go ahead and look through these 5 questions. All right, hopefully you have written these answers down or jotted them down or thought through them. Number 1, and if an atom has 11 protons, which element do I have? If I go to my periodic table and I see 11 here, 11 is sodium, so the answer would be sodium. For number 2, if an atom has 12 protons and 13 electrons, what is the charge? So if I take 12 minus 13 using the equation I wrote down above, I get a -1 charge. I have an ion. Number 3, if an atom of aluminum has a +3 charge, how many electrons does it have? This is slightly more difficult. I first need to go find what the atomic number of aluminum is, so I can find out how many protons it has. So I have 13 protons. If I have a +3 charge, I'm going to have +3 is equal to 13 minus what? 10. So I have 10 electrons here to get that +3 charge. Number 4, if the mass number of carbon is 14, how many neutrons does it have? Again, mass number is protons plus neutrons, so I need the mass number of carbon. I go to my periodic table. I don't need the mass number, sorry, to find mass number, I need the number of protons. So the number of protons of carbon is 6. So if my mass number is 14, I'm trying to find neutrons. 14 is equal to 6 plus what? 8. So in this case, I have 8 neutrons making up the nucleus in this carbon. Last but not least, number 5, what is the mass number of an isotope of nickel with 31 neutrons? So again, mass number is protons plus neutrons. I have 31 neutrons, so I need to find the number of protons in nickel and add them together. So if I go to my periodic table, I have nickel here in the middle, transition metals. It has 28. So 28 plus 31 is going to give me 59. So I have a mass number of 59 for that species. Last but not least, you're going to go ahead, you already have your computers out, open up this tiny URL. You're going to read through the article. There are 5 postulates that you're going to jot down. Dalton was the first person who really thought about atomic structure, and that his postulates are wildly crazy, still mostly true today. There are a few that are not true that hopefully we will identify as we continue working. But I want you to jot those down in your notes. And then once you finish that, we are done with today's topic and you can move on to our next lesson.